Hi, I'm Ahmed Al-Qawlani. Today I'm telling you a secret about drugs regarding our health. Recently, pharmaceutical companies have been competing for controlling medical marketing by producing better and more available drugs to the markets around the world. Therefore, when a pharmacy technician gives you multi-different products of various companies based on their qualities effect for the same order doctor had prescribed for you is not our topic. What is important and related to this video is when giving you different quantities amount of a sample drug. For example, administration of a painkiller to a patient with a post-operated pain of a tooth replaced surgically, whether giving them 100 milligram of ketoprofen or giving them 50 milligram of dexketoprofen in every 8 hours over the 2 days with the same result of relieving pain. So, to know the secret behind giving different quantities of drugs, watch this video till the end. Stereochemistry, which has a huge impact on chemical fields, is revealed to studying chemistry in 3 dimensions and also called a heart of chemistry. Isomers are compounds with the same molecular formula but differ in their physical or chemical properties. Isomers subdivide to constitutional isomers and stereoisomers. Constitutional isomers with the different connectivity, for example, ketone and aldehyde. Stereoisomers, the same connectivity, but they differ in their arrangement of their atoms in space. Stereoisomers subdivide to enantiomers and diastereomers. Enantiomers with a mirror image, non-superimposed, optically inactive, which means they don't turn right to left or right in polarimeter, and they are chiral, which means they have more than chiral center. For example, ketoprofen. Diastereomers are not mirror image, non-superimposed, and optically active, and characterized by chirality, which we'll discuss later. Structure of ketoprofen, for example, ketoprofen has two benzene cycles connected by carbonyl group attached by isopropanoic group constituting of 16 carbon and 14 hydrogen and 3 oxygen atoms. Chemical structure of ketoprofen. Here you see the chiral center on carbon number 2. The importance of stereochemistry is increasing receptors selectivity and potency of the drug in the body, decrease the adverse effects of the drug, decreasing the dose given to patients, which means the amount of drugs, decrease the potentially drug-drug interactions, and increase the safety margin, which means the therapeutical index. Chirality, a carbon atom with 4 different groups attached to it. Here you can see carbon attached by 4 different atoms. When a molecular has more than one chiral atom, we calculate the number of their isomers by this equation, 2 power n, while n is the number of chiral centers. For example, a molecular with 2 chiral centers give us 4 isomers. chirality vs mirror image. A chirality can't be superposed point for point on its mirror image. A picture of a left hand is giving us a mirror image of the right hand, like this. Chirality vs mirror image. Here, as you see, the rotation is about 180 degrees around the vertical axis, and when a two pair of molecules are mirror image to each other, chirality is responsible to optical activity in a molecular. Enantiomers are similar in all physical and chemical properties, except they differ in their effect of plane polarized light with the same magnitude but different signs. For example, when a 2A and P separated enantiomers tested for their optical activity, A turns light 180 positive, while B turns light 180 negative. The rate of reaction with other molecular of chiral compounds and their physiological effects. Physiological effects, for example, their agonist or antagonist or a toxic in tumors. Ketoprofen in tumors, as you can see here, the S-ketoprofen and the R-ketoprofen. For example, when one in a tumor may have the all activity while the other is inactive, as in non-steroidal anti-inflammation drugs, as in the ketoprofen. The ketoprofen, the S-ketoprofen is an active while R is non-active. The configuration of enantiomers. We have the sequence rule of the higher atomic number of the substitution atoms is the higher the priority of the atom. Here you can see the hydrogen atom is placed behind due to its low atomic number, and you can see here the sequence goes. Here the chloride is labeled 2, taking the priority of fluoride, while the bromide is labeled 1, taking the priority of chloride, and the sequence goes in a clockwise, giving us the R enantiomer. And here you can see the opposite of the sequence of the first one, and it goes in anti-clockwise, giving us the S enantiomer of the molecular. The configuration phase rotation. Here there is no correlation between the S and R configuration and positive and negative rotation. So the configuration of S and R is based on the arrangement of substitution atoms around the chiral carbon, while rotation of positive and negative is based on the turning light in polarimeter using experimentally in laboratory. And here you can see the R configuration may be positive or negative, and also as ketoprofen may be can be positive or negative. Rhythmic mixture, a mixture that contain equal amount of bare enantiomers is called a rhythmic mixture. It is optically inactive. Why? Since the enantiomers rotate the plane polarized light in equal but opposite direction, the net result of optical activity is zero. Here you can see the ketoprofen in a mixture given as R ketoprofen 50 while the S ketoprofen is 50. Rhythmic mixture in factory. When a rhythmic mixture have more than one chiral carbon, difficult to be separated in laboratory. Like cholesterol, which has 9 chiral center, so its isomers equal 512 isomer, and it is difficult to be separated. Resolution of a rhythmic mixture. Here you can see the S and R diastereomers in a rhythmic mixture. We add a single compound of an enantiomer R as a chiral reagent, so they result in a diastereomers product separated easily because they are different in melting point and boiling point and their solubility. A model of a rhythmic mixture. Here you see the S and R enantiomers adding a different single enantiomer given as the intermediate species, resulting in R enantiomer 50% and S enantiomer 50%. How the drug works on the body. The non-steroidal anti-inflammation drugs works on, as for example, the ketoprofen works on COX-1 and COX-2 enzymes, which produce the prostaglandin. Prostaglandin is a hormone made at the damage of at the site of the damage, and is using as a signal for pain and inflammation. So the decrease in enzymes give us the decreased the prostaglandin amount, and they result in decreasing pain and inflammation. How the body metabolize the drug. Metabolizing of ketoprofen primarily in liver through the conjugation of glucuronic acid in phase 1 and 2, and it is eliminated through kidney in urine, about 80% of the drug. The main usages: they reduce inflammation, they used after post-surgical pain, and they relieve pain of rheumatoid arthritis and the osteoarthritis, and for women through period, the menstrual pain. Side effects of ketoprofen: vomiting, diarrhea, and inappetency, and lethargy, and others. Comparison between dexketoprofen vs the ketoprofen. The absorption is faster while the ketoprofen is slower. The efficacy of dexketoprofen more efficacy than Ketoprofen. The safety the Dexketoprofen more safety, while the Ketoprofen less safety. The dose of Dexketoprofen, we use less dose, while the Ketoprofen is large dose, the amount of drug, and the half-life of Dexketoprofen 8 hours, while Ketoprofen has a low half-life, 2 to 4 hours. Dexketoprofen drug model here. The end. This work is dedicated to our Professor Mokhtar al-Ghorafi. It is done by students of a second year in Pharma in 21st of September University, produced by Ahmed al-Qawlani.